Hello everyone, I'm Ashok. Welcome to the tutorial on end-to-end machine learning deployment. I agree that data scientists or machine learning experts doesn't need to really know the deployment because that's a complete different division. We have deployment architects, release managers to take care of that. But having said that, if you understand how it is deployed and if you can do it by yourself, it's really interesting because you can host your own projects, a hobby project or a non-profit project which you have just designed a model and you want to make it available for public, or maybe a smaller client who needs a standalone machine learning application to be deployed. So in these cases, you don't need any support if you can do it by yourself. That's the motive of this video. And there are several ways we can do it. This is actually a very basic way, but still functional. We can use a production level applications by doing this. So I'm going to split this video tutorial into two parts. Part one, we're going to go to the data preparation. We have a data set, we'll load it, data preparation, we'll model it, we will evaluate it, and then we export the model. And then we use FLASK API server to create an API, REST API, and create a web page, a website to interact with this API and show it as a proper application. Part two, I'll be using Amazon Web Services for cloud service. So we'll be spinning off an EC2 server, Elastic Cluster server from Amazon Web Services, and move all of the files we have done locally to the cloud and make this service public. So basically, and probably we also buy a domain and link it to it. Domains are very cheap nowadays, so it becomes a proper application available online. Great, I'm very excited. The data set I'm going to use is actually predicting marriage age. It's a very interesting topic because recently you can see that currently I'm staying in India, Bengaluru. So the marriage age, the age of the marriage is actually getting delayed. It was few years, at least 3 to 4 years less, 5 years before. Now it's going near to, for at least for IT professionals, it's near touching 30 for male, 30, 31, and female around 29, 28, 28, 29. So and there's a lot of factors, but that's not our topic. So our topic is to actually collect the data of the people who got recently married 2 3 years, from 1918, 1919, 1920, and create a predictive model which is based on certain things like what's your religion, what's your caste, because in India still caste system is very prevalent, and the practice of marrying early and late is also related to caste very much, and other things like which location are you from and what's your education and other things. So taking this into consideration, if you can predict the marriage age, that will be really interesting project. So I would like to thank Datamites Institute students who are institute which I train. They help me a lot in collecting this data because data collection is a very important thing, and it's actually takes a lot of time. So let me just get into this. I'm going to import. Hope it's visible. Yeah, okay. So I'm going to import pandas and data is equal to pd. I hope it's CSV file. I put it in the same folder. It would be no, it's not that. Age of marriage data and data. So all right, so this is the data. So we have gender, height of a person, religion, and I do see some nans, so that needs to be treated, and caste. I'm not very good in that, so I only know very few of them. Mother tongue as a language, profession, location. We also have abroad data, so mostly Indians living in other countries, NRIs, and of course the age of the marriage. Okay, the first record is someone from London got married in 21 years. That seems to be outlier, very extreme. It's too young age. All right. So I'm going to do a bit of analysis and see how many duplicates we have. Quite some duplicates. Highest is profession, 330, and the religion is actually quite high. Let me check if I can drop it and look at the shape. The total number of records we have is, print it out. Okay, so after dropping, we have 1932, which basically means I can actually do the percentage calculation. Let me check. So 24% records have missing values. Ideally, I'm supposed to replace with we have to treat the missing values, called as imputation. But I'm not going to do it because the purpose of this video is not machine learning tuning or modeling. It's more about deployment. So I'm going to go ahead, drop all the values. I'm happy with 1900 records. So I'll say drop NA. So in place is equal to true. So drops all the records. So let's look at my data now. Shape of it. That's okay. So we have 10 fields and 1900 records. Okay, so I'm going to make a very quick, feature engineering. I'm going to pick up certain variables which I think will be useful for the model. Gender is definitely because males in India tend to be marrying a little later than females. Height, I don't know. Maybe if you're too short, then maybe you find difficulty finding a partner. I don't think so, but it could have some influence. Religion, yes, the marriages, the age you marriage really depends on religion. Caste as well. Mother tongue and caste. Okay, mother tongue and location might be pretty much same because yeah, if you're from a certain place, then your language, mother tongue will be. So if you're from Gujarat, you'll speak Gujarati, for example. Yes, and the country where you're staying matters because if you're staying abroad, but the first case is a little exception, but typically you might marry a little later. And the last one is our target variable, which is the age of the marriage. So I'm going to quickly take certain x's. I'm going to do this data.loc, take all the, I'm doing it in a very traditional way, so keep it very simple. So gender, height, religion. Okay. I could actually look into the cast. Let me just do a simple exploratory data analysis from, I use pandas profiling. It's pretty straightforward. Mm-hmm. Into loss to convert to a float. Which one? Okay, some mistakes. Which column is that? Okay, no worries. So let me just do it in a simple manner. Cast. And see how many unique values cast has. Um, I think that's okay. I think we can handle that. How about location? Is it location spelling correct? Oh, sorry. Data location. My apologies. So That's too high. I'm not going to take it for now. And what else we have? Profession. Let me look at the profession. Okay, so I'm going to drop that as well. Okay, so if you're doing a proper analysis, then probably you need to get all of these things to be treated. But right now, I want to do things a bit faster. Tongue and country. I think that's good enough. And my Y is of course data dot marriage age. Excellent. So I'm going to use a quick algorithm. Any algorithm is fine. I'm going to use random forest. That's pretty straightforward. And before that, train test split from. Okay, even before train test split, we need to do the label encoding because these are all numbers. So these are all strings. I need to convert them into numbers. So I'm going to do a label encoding quickly. sklearn preprocessing import label encoder. Let's say nc is equal to label encoder and so data again I'm not doing any shortcuts here, so I'm trying to stick to the standard formats to make things simple. So as the video says, it's the simplest way of doing things. Religion, caste, mother tongue, and country. So I'm going to say the same thing again with apply. Oh, okay, it's becoming too small. Let me get into the next line. If you put a backward slash, it just comes to the next line. I'm using apply function of pandas so that I can simply say fit and transform. It does it in one go. Transform. Okay, so this will, okay, some mistake, nothing wrong. Let's see. Okay, I don't see anything wrong. This is fine. Okay, good. So they have basically converted all of these things except, sorry, I'm looking at data X. So nothing happened. Oh, sorry. Screwing up a bit. My apologies. Just going through all of this, and here I'm supposed to do the encoding for X, not for the entire data. Okay, so I have done that, and I do have a one more field. Height is not really a numerical field. Height is in inches and feet and inches. So I need to convert this into centimeters. So it's going to take a bit of time. Let me check very quickly. So I'm converting the feet, inches into centimeters. So that's what I'm doing now. Let me just know what's the values. Feet to centimeters. It's 30.48. I'm going to multiply this with 30.48 and put an integer. Okay, what happened? Can't multiply sequence by, okay, first I need to convert into integer and then multiply with this. That's perfect. And then the second part is actually converting the inches into centimeters. It's 2.45, 2.54, isn't it? Yeah, 2.54. What happened again? Okay, I need to replace that inches. Replace that, this thing, with nothing. And then I split this one. I've taken this. Then I have done this. Okay. Okay, so that's second part. So I have converted feet to centimeters and then inches to centimeters. Just gonna combine these two things. Okay, so this is just getting to the next line because it's too big. So this is what the logic is. I'm going to define a function for this. That will be really easy. So I'll say def height centimeters kinds function takes a height in feet and inches and converts it back into centimeters. So I'm going to simply remove all of this. I'll put h here and h here. I think that will take care of it. And of course I have to return this one. That's the value I'm returning. Okay, so I'm going to apply this for the heights. X, I'm going to create a new column called height centimeters, and I'm going to say height apply HCMS. That should do it. Okay, so I have all the height being converted into height centimeters, and I don't need the height anymore because I have already converted. So I'm going to drop the height column. I'll say drop, so in place is equal to true. Okay, I have to say axis is equal to 1 because it's column. Okay, done. Great. So all the data cleaning is been done and the data is clear now. So now I'm going to build the model. For building the model, I need to do data splitting, which I'm going to use train test split from model selection. Train test split and say x train, comma x test, y train, comma y test is equal to train test split x comma y. I'm going to take a test size because we have a less data. I would like to put 20% as a test size, and I'll put a random state of 0 or something, just so that the shuffling order is fixed. Okay, so the splitting is done. Now it's modeling part. I'm not putting any documentation, but when I upload the code back in GitHub, I'll ensure that I'll put all the documentation required. sklearn, I'll go with ensemble technique, random forest, classifies regressor because age is a continuous value. I'll say model is equal to random forest regressor. I'll say model dot fit x train, y train. Once the fitting is done, then I'm going to say model y predict is equal to model dot predict. I pass on next test. So that completes your, it's a warning. It says that number of estimators in random forest is moving from 10 default to 100. So I'll put 100. So the warning will go away. And the evaluation part now. So I'm going to take matrix import mean square mean absolute error. That gives me a better picture. MAE mean absolute error. Okay, so my model is predicting a marriage age with 1 year. So it's not really great. I mean, I would be happy if it is like 3 months or 4 months. So you say that you get married at 29 years 4 months, and you're getting married anywhere between 29 and the end of the 29 years. That'll be fantastic. 1 year is like, if I say your marriage age would be 29, then it would be between 28 to 30. So it's not very nice, it's not very accurate, but given that I've taken only few variables, I think this is fairly enough. I'm also going to print auto score just to see. um, so I expect about 65 score to 70 score. Let me check. Yeah, 68. We can do a bit of fine tuning. Not really going into it, but if you really want to do it, I can do a bit of fine tuning. Okay, got a bit improved. So I'm not going to do a extensive fine tuning over here. Model seems to be overfitted a bit. Now it's okay. Yeah, I think this is pretty good. 70% auto score. That's auto score is 70%. That's good. Great. So till now, most of you, if you are into data science, machine learning, would have done very comfortably, and you would have used a lot of fine tuning methods and a very detailed feature engineering and data transformation, and get a best accuracy possible. From here, I want to deploy this model in an API form so that I can extend this service to other applications. So for that, first we need to export the model. Export the model. I'm going to use an inbuilt module in sklearn, scikit-learn, called joblib. That's in externals. So scikit-learn dot externals, externals import joblib. Okay, and I'm going to say joblib dot dump. So I'm going to dump this model. What I have trained till now, the random forest model, I'm going to simply dump it. Dump it into a file. What you would like to call this file? It's marriage age prediction model. Quite big, that's okay. You can, joblib is .ml is okay. Could give any name. What happened? So joblib is deprecated, will be removed. Okay, import this functionality directly. And what is replacing this? Okay, I'm going to ignore this. Okay, and if you look at the folder, now you actually got a file which is a trained model. I can import this file in another. I didn't really name this file yet. Let me just name this file first. This is machine learning marriage. Okay, let's machine learning marriage age prediction. Okay, so I'm going to create another file just to show that. So in this, if you want to use this exported model, we can import it by using the same library. I'm going to say sklearn dot externals, import joblib, and I can say model is equal to joblib dot load. I can load that model. This is the file I have just exported. There's a spelling mistake in it, that's okay. There's a T is missing there, that's fine. The same file has come. And some warnings, you can ignore that. Run it again, it goes off. So now that I got the model, now I can predict my marriage age given that I give all the predictors in the same manner. So what were the predictors we have? We have gender, height, religion, caste, mother tongue, and country. I don't know the numbers. We could actually find the numbers because we have used label encoding. So we could actually find the numbers. How come this is after label encoding? Okay, let me just run it from the top one more time. Label encoding it changed. So let's say I'm a Brahmin of Hindu religion, 175 centimeters height, which is my height, 176, male, and I speak Hindi, and I'm from India. So let me put those values. Gender, height, religion first. So gender is male, 0 is female, M is male because F comes first. Gender, height, and religion. No, I think the height has been changed. The height actually comes. Okay, so this is where height actually comes. Gender, religion, and then caste. Religion, I put some religion. Caste, I'm going to put some caste. And then mother tongue, I'll just put some number. Okay, it's okay. And then country, again, height 175 centimeters. We run it, and I got married at 29 years. That's very interesting. Okay, great. So this is your model. We have done the modeling evaluation, exported the model, and loaded this model in a separate file, and managed to predict using a static values. Now, what I want to do is I want to create an API, a REST API, where anyone can actually, request it by sending the predictors and get the predicted marriage age. And that's the goal of it. So in the steps, we have covered preparation, modeling, evaluation, exported trained model. Now we're in fifth step where we are creating a REST API, a local REST API with a FLASK server. Let me create a text file for it because it needs to be a Python file because we're going to run it in a separate thread. API web server is always live and running, so it requires a separate thread. I'm going to call it as app.py. Okay. I've already installed Flask as well as Flask cards, which requires for cross-domain authentication. I will leave this code as well once I have complete writing it. So I'm going to import Flask, and from Flask import request because we need this for reading the URL parameters because we need to send the parameters to URL. I can initiate the app saying Flask Flask, and I can give the default structure. So this thing you can actually find it from the Flask repo. So you have a standard Flask template import cost. So this cost is required for cross-domain authentication. When you're hosting the application outside your, let's say you're hosting in Amazon Web Server, and you like to actually, anyone from outside can actually send a request, then it requires cost. The cost it's needed, and then there is a default way of writing the routes. Route spelling is right. If anything is wrong, it will say, and I will correct it. And then I say definition, I can say default, or I can give any name. So I'll say default right now, and I'm going to return um, a quick h1 tag saying it's working. As an API server is working. H1, great. Okay, so and then I can simply say app.run. So you can find a extensive code, but this is good enough. I mean, this actually is a very bare bone. I initiated a Flask object, passed it to COS for cross domain authentication, and created a default route. So I'm going to save this file. It's saved. Now to run it, you need to go to you need to have a separate terminal, and then I need to navigate to the. So let me just copy this. So for you, it might be the same folder. So all of my files are in cloud, Google Cloud. So I need to navigate there, and then I have this marriage age. It's not a directory. So what was the folder I'm working on right now? Marriage age predict. So I'm gonna say cd. I don't know if you are able to see it. cd marriage age predict. Okay. Okay. So this is where I am right now, and my app app.py file is in this folder. I'm gonna simply say python app.py. Okay, there's some problem. Name is not defined. What is it? Okay, got some error. Cleared it, and let me try one more time. Okay, so it's running now. The port was occupied by another application in my local system which I ran before, so that was a problem. Let me put this back. So API is working. So we have just created a REST API using Flask web server, a lightweight web server. So when we are using production, like when we do it in EC2 in the next video, we will be using WSGI, because WSGI is a production level server, and it can handle multi-threading and multiple simultaneous requests, and all the production level configuration uh, properly. So Flask, local server running with the Flask. Now, what I'm going to do is I'm going to create another route. So I'm going to create another route, and I call it as predict. Okay, and let me just look at this predicting. Okay, so if I go to the web browser and say /predict, so okay, again, what happened? Oh, I'm using the same function, so it has to be a different name. So I'm going to call it as predict itself, because that's the route name as well. Save it and run it. Yeah, because of this error, the web server would have got stopped. So now it's running again. Okay, predicting. So that's the route we have just created, and in this I would like to import the file just like what you have done here. I can even copy paste this. Just copy this one, paste it. Okay, so I imported the job name and load the model, and then I'm going to say age predicted is equal to, I'm going to predict the age. So say model.predict. I'll just copy this again. Same thing. Great. And return the age predicted. Great. So I'm going to save this. Now I run the predict. I will be seeing a, okay. Did not return a valid response. It should be a string. Okay, no problem. I'll make it string str because that was a float. So I got error. Okay, so as you can see, 29.5, that was my age, the same value. So my API is able to route to this module and predict the age. One last thing to do, these are static values. I would like to have a dynamic values over here. For that, we have a request, FLASK request module. So I can simply say um, I'm just putting in a nice order so it looks better. So I'll say request.args. What was the first one? It was gender, isn't it? It's gender, correct. So I'm gonna say gender. All right, just save this and run this. How do you pass an argument? It's a get request, so I'll be passing it directly from the URL. I'll say gender is equal to 0 for male, 0 for female, 1 for male. So 1, if I give 1, so I would be getting the same my age. If I make it 0, then it will be less. Yeah, see, usually in India, females have 1 or 2 years lesser age in terms of marriage, for given the same caste and same religion, all the things to be same. In the similar manner, I'm going to simply copy this one more time and replace all of this with arguments so that I can pass all the arguments from there. First one is gender, second one is not this is the last one. Religion, caste, mother tongue, country, heights in centimeters. Let me put them all in. Religion, caste, what was that? Mother tongue, country, and height. Mother tongue, country, height in centimeters. Okay, perfect. So if I should be giving all of them here in the same fashion. So if you want to use multiple URLs, it is separated by an ampersand symbol. So you say gender is equal to 0, ampersand, and then caste is equal to, I don't know, there should be some number. So I don't know what is that. I can tally that later. Caste is equal to 2, and religion is equal to 2 as well. I think it's Hindu. And what are the other things? Mother tongue, country, and heights in centimeters. Mother tongue, I'll say 5. I think 5 is for Hindi. And country, India is 5, I guess. And then you have height underscore centimeters. I'll put 175, which is my height. So 28.5. So it's actually taking these values dynamically from here, from the URL, and passing on to the function predicted. And this prediction is happening from the trained model we have exported, from the modeling we have done, and that completes all of your the work. So API is fully functional. In the URL, I can actually change these values. Let's say, I'm just curious. Let's say I change my gender changing, obviously it will increase because 31. So 1 is male. That's the only thing we know, because other thing I just use a label encoder. I don't know which number belongs to what, which I could actually find out if I do the label encoder classes, and which we will do it in later, the next part. Okay, one last thing is I have HTML file which I have asked my colleague to actually create it. So it's a simple HTML file. If you just HTML file which takes few things like age, gender, religion, caste, mother tongue, and country, the same parameters we used, also the height, and gives you the marriage prediction. Okay, So in this file, it can run from anywhere. So currently it's running on my local system. In this file, oh, I already put this local host. This is the IP number which my current local API is running. So all the things are actually in place. So it should be working off the box. Let me see. Here I can actually give my whatever. I'm a male. My religion is Hindu. Caste. I doesn't matter. Mother tongue. My mother tongue is Telugu. Where is my mother tongue? Here it is. And country is India. Of course, currently I'm in India, and my height is 175. So then I say submit. So my age prediction, I mean, it's predicting me. Actually, I'm not from Brahmins. Where is my? I'm very poor in caste system. I don't know which belongs to what. So either way, it's giving me a prediction of 31.4. So that's my marriage age. Let me change the male to female, something which you can easily understand. Yeah, it comes a couple of 1 or 2 years less. Great. So this is your part 1. So we have got the data, cleaned it up, and trained the model, evaluated it, exported the trained model, and then created a Flask API, connected the Flask API through our to our trained model by doing this. So I have simply loaded this over here, and then taken URL arguments, passed it to it, and it actually gives back the result. And had a small HTML file. This is actually pretty small HTML file, 4 or 5 uh, fields, and I have a small pull down menus over there. So I'm just giving all the details. When I submit it, these values goes back to my API, and it basically it predicts from by loading the exported trained model, and it shows the result over here. Great, fantastic. And in the next part, we shall move this into a EC2 server, a cloud server, and make the domain public. And that's the next part. Hope you enjoyed the video. If you like the video, please subscribe. Also, click the notification button. If you have any comments, questions, if there is any error, which probably yes, because I face many errors as well, please leave it on the comments. I'll do my best to answer all of them. Thank you very much. I'll see you in the part 2 video.